Welcome back to my channel. In this tutorial, we'll dive into a hands-on lab where we'll be setting up a Docker-powered AIOps monitoring solution using Prometheus, Node Exporter, and Grafana. Let's get started with the practical steps. Here's the architecture of our AIOps monitoring setup. As you can see, it involves Node Exporter for scraping system metrics, Prometheus for storing those metrics, and Grafana for visualizing them on a dashboard. All of these components communicate through a Docker Bridge network, ensuring they can work together in an isolated and secure environment. We've discussed this architecture in detail in a previous video, so I highly recommend checking that out for a deeper understanding before proceeding with this lab. It will help you follow along more effectively. Now, let's begin by installing Docker. First, open your browser and search for Docker for desktop. Since we're using a Windows-based operating system, we'll be installing Docker on Windows. The installation process is straightforward. Download the installer from the official Docker website, and once it's downloaded, simply run the installer. Just follow the basic steps by clicking Next. One important thing to remember is to ensure the WSL2 option is selected during the installation. This allows Docker to run efficiently on your system. Once you've selected that option, click OK, and Docker will begin installing on your system. The whole process should only take a few minutes. After the installation, Docker should be up and running, ready for us to use in this lab. Once Docker is installed, the next important step is to validate that Hyper-V is enabled on your system. Hyper-V is a virtualization technology that Docker requires to run containers effectively on Windows. To check if Hyper-V is enabled, open Command Prompt as an administrator and run Get Windows optional feature command. If the state shows as enabled, you're good to go. However, if it's not enabled, you'll need to activate it. Run dism-exe command to enable Hyper-V. Once you execute this command, Windows will enable Hyper-V, and when the process completes successfully, Docker will be able to function properly. Now, we need to install Visual Studio Code. To do this, simply open your browser, type VS Code, download, and download it from the official Microsoft website. The installation process is straightforward, just follow the steps by clicking Next. I've already installed it, so let's get started with the setup. Once you have VS Code installed, open the application. Click on Open Folder and select the folder where you want to create this project. In my case, I've named it AI Ops Lab. Next, click on the Extensions tab on the left-hand side of the screen. From here, search for and install the Docker extension and the YAML extension. These will help us manage Docker containers and write configuration files with ease. Now, we'll create a new file. Click on New File, and we're going to name it Prometheus YAML. This file will contain the configuration for Prometheus, which we'll use later in our setup. Now that we've created the Prometheus YAML file, let's go ahead and configure it. This YAML file defines how Prometheus will scrape metrics from different targets. As you can see, we have two script configs in this file. The first one is for Prometheus itself, and the second one is for Node Exporter. Let's go through this quickly. The scrape interval is set to 5 seconds, which means Prometheus will scrape the targets every 5 seconds. Under script configs, we define two jobs. The first job is named Prometheus, and it scrapes metrics from localhost port 9090, where Prometheus is running. The second job is named Node Exporter, and it scrapes metrics from Node Exporter port 19100, where Node Exporter is exposing system metrics. Now, click on Terminal in VS Code and select PowerShell as the terminal type. In the terminal, type Docker version to validate Docker running correctly. One important thing we need to do now is to click on the Docker desktop icon on your screen. This will open the Docker application where you'll need to accept the service agreement. This step is typically done right after installation, but if you missed it earlier, go ahead and accept the agreement now. Once that's done, we'll start setting up our Docker environment. Next, we'll create a Docker network. This network allows the Prometheus, Node Exporter, and Grafana containers to communicate with each other. Execute the command as shown here on the screen. First command is to create a virtual Docker bridge network that all the services will use. Now let's run Prometheus inside Docker, using the network we just created. We'll pass the network flag to ensure Prometheus connects to the same Docker bridge network. This command starts Prometheus, downloads the necessary image, connects it to the My Local Network lab network, and mounts the Prometheus YAML configuration file that we created earlier. You can check the Docker container by executing docker ps and docker image command. Now we'll run Node Exporter. As before, we'll pass the network flag to connect it to the same network. Execute the docker run command as shown on the screen. This will download the Node Exporter image, start the container, and connect it to the Docker network we created. Finally, we'll run Grafana. Like Prometheus and Node Exporter, we'll use the network flag to ensure Grafana connects to the same Docker network. This will download the Grafana image, start the container, and connect it to the same network. To verify that everything is running correctly, type the docker ps command to list all running containers and check their statuses. Here, you'll see the images installed and running, as well as the ports they are hosted on. Grafana will be running on port 3000, Prometheus on port 9090, and Node Exporter on port 19100. Check network status using docker network inspect command. Alright, now that all the containers are up and running, we are ready to connect Grafana to Prometheus and start visualizing the metrics. Hi. Now that our containers are up and running, let's start by browsing Prometheus. Open your browser and type localhost port 9090 in the address bar. You should see the Prometheus UI, where Prometheus is scraping system metrics. Next, let's browse to Grafana. In a new browser tab, type localhost port 3000. This will open the Grafana login page. The default username and password for Grafana is admin. Once you log in, Grafana will prompt you to change the password. Feel free to do that or skip for now. Once inside Grafana, let's set up Prometheus as a data source. On the left side of the screen, you'll see a sidebar. Navigate to Data Sources and click on it. Now click on Add Data Source. You'll notice Grafana supports many data sources, including MySQL, CloudWatch, Azure Monitor, and more. For this lab, we'll select Prometheus as our data source. After selecting Prometheus, we need to configure the connection. In the URL field, type HTTP Prometheus port 9090, which is where Prometheus is running. Once that's entered, click on Save and Test to verify the connection. Grafana will confirm the connection is successful. Now you're all set to start building dashboards and visualizing the metrics being scraped by Prometheus. Now that we've successfully connected Prometheus to Grafana, let's create our first dashboard to visualize system metrics. Click on Dashboard from the left side menu and then click on Create Dashboard. After that, click Add Visualization. For the data source, select Prometheus. Now we'll configure our first visualization. Let's start by populating CPU usage. On the right side under Panel Options, give the panel a title like CPU usage. We'll now use PromQL to write a query for the CPU usage. Once you've written the query, click Run Queries. You should now see the CPU usage graph appear. Click Apply to save the panel. Now let's add a few more panels to the dashboard. First, make sure to save the dashboard to keep your changes. We'll go through the same steps to add additional panels. Click on Add Visualization and give the panel a title like Memory Usage. Run the query and you'll see the graph for memory usage. You can also select different visualization options on the right panel, such as graph, gauge, or bar chart, depending on your preference. Once you're happy with the visualization, click Apply. Next, let's create another visualization for disk usage. Repeat the same steps. Click on Add Panel and give the panel a title like Disk Usage. Finally, let's add a panel for network activity. Follow the same steps as before. Click on Add Panel, select Prometheus as the data source, and give the panel a title like Network Activity. Click Run Queries, visualize the data, and click Apply. Once all the panels are added, you'll notice that you can drag and drop each visualization to arrange them on the dashboard. Grafana also provides advanced customization options, allowing you to change the color scheme, display type, and more. Feel free to explore those options to make the dashboard your own. Once you're happy with how the panels are arranged and visualized, don't forget to save the dashboard to ensure all your changes are preserved. Now, let's take a look at our CPU usage visualization. To test this out, I'm going to simulate high CPU usage. I'll trigger a command in PowerShell that replicates high CPU activity so that we can observe the changes in real time on the dashboard. Keep your eye on the CPU usage panel. Once the command is executed, you should start seeing spikes in the graph, representing the increased CPU load. And that brings us to the end of this tutorial. We've successfully set up a monitoring dashboard using Prometheus, Node Exporter, and Grafana to visualize real-time metrics such as CPU usage, memory usage, disk usage, and network activity. We also simulated high CPU usage to see how it reflects on the dashboard. Thank you so much for watching, and I hope you found this tutorial helpful. Be sure to subscribe and stay tuned for the next video where we'll dive deeper into more advanced AI ops concepts and use cases. See you in the next tutorial.